Hello, I'm Miroslav Blaško, and I would like to present you a paper, results of a paper that investigates senior software developers' productivity when using AI. The presentation will be presenting some parts from the paper, while motivation and discussion will be extended with use case related to our group KBSS. So let's go to the study, to the paper that investigates performance of AI with developers. The study itself was done by METR, which is research-focused organization, and the motivation was to complement existing benchmarks because current benchmarks are are typically self-contained tasks with no context, which are evaluated algorithmically. That means there are automatic tests that either fail or pass, and typically with that it misses key skills like how the code itself is maintainable, extendable, and so on. So in that sense, for code that does not have to live in any other context, it doesn't have to be continuing some implementation. Here are the capabilities of AI a little bit overestimated. On the other hand, it is also underestimated because those tests are evaluated, and even very small mistake of AI could lead to failure of the test. But if we would put a human into the loop, it might he or she might solve little bottlenecks. So we can say that those typical benchmarks do not measure real-world impact of AI on software development. And this is the motivation of study to provide complementary evidence to benchmarks, and also to understand AI's impact, which is the goal of the organization. Also, my motivation is to promote discussion and investigate improve productivity of AI tools at KBSS. So the methodology of this randomized control trial was as follows. There were 16 senior developers that together worked on around 250 issues. The developers had to be working on repositories that are well known. At least they should have at least 1 million line of code, and they should have been multi-year contributors to that repository. Each task took about 2 hours to complete, and they were randomly assigned whether they could or they must not use AI. Here is a workflow. So developers were assigned issues, and for each issue they had to do forecast how long it would take with and without AI, and then they would have to implement. after random decision, after random selection, they were either assigned to do it without or with AI. With AI, they could use any AI available. They were even trained how to use it, and they had to implement the issue, open pull request, address review, merge, and then report how long it took. Based on this report, this value was created. On the forecast, this value was found out. The value itself basically come from a ratio between time with AI and time without AI. So so here would be the ratio for the forecast, and from reported time, it would be here. The last estimate was when developers finished all the tasks. They were also asked how much speed up the AI provided them. What they think, how much speed up it provided them. So forecast before they started implementing, for estimate after they finished all the tasks, and this is real measurement of their time. They also asked experts to estimate while giving them enough information how the experiment goes, of course, without knowing existing issues. And they motivated experts with money. The better they would estimate, the more money they would get. There was a kind of formula to pay the money to those experts. Also, developers, after they finished tasks, they were asked to label their recordings according to some guidelines that were provided to them. So they had to tag time intervals within the recording with appropriate labels. So that's it, and the results are here. Basically, the ones that we showed here, but a little bit more precise. So when they ask economics experts and machine learning experts, they would provide for around 40% speed up, a little bit less, as you can see. They were forecasting this, while developers were forecasting 24%, and after they finish the task, they estimate it still the AI still helped them, and it created speed up of 20%. But the actual observed time was minus 19%. So there was actually not speed up, but slow down when using AI. This is basically detailed look on the same graph, but restricted to developers. Yeah, this is also the confidence interval 95% here as well. So here are the forecasts. You can see that it was done on 246 issues, while 110 issues were done without AI. The rest was done with AI. It is quite interesting to see that the estimation of time of developers were doing quite good. This graph is about screen recordings. As I mentioned, they were supposed to annotate their activity while programming. Oh, not while programming, after they finished. So here you can see that when using AI, there are many additional activities that you're doing that you would not do when AI is not allowed. It can be seen that active coding is shorter. Of course, not of course, but not very surprising is that testing and debugging is a little bit increased. But what is very interesting is this idle overhead, which was discussed there in bigger detail, but basically 80 or 90% of this is no reason. So developer could not say what actually was happening there. So this is very interesting that some kind of idle time is happening there, and it could be nice to investigate it more, but the paper didn't do that yet. So yeah, let's go further. They although didn't have statistical significance, they they listed 20 factors that would cause the slowdown, and five of them were selected like those that are most probable, and those are over optimism about AI usefulness. So it says that people are using AI more than they should. Then high developer familiarity with repository. They were asking developers about how they feel about the task they are going to implement, whether they know how to implement or they are not sure, and when they reported that they are quite sure with some scale, and they also asked about external resources. That means how much they need to Google or how much they need to find additional information when they need to implement it. So how much? So for example, some external libraries or even internal libraries which they do not remember, so they have to investigate, and based on that they found out that the more is developer understanding the task and the less resources he needs, the more effective he is. So AI is not useful in case you are very familiar and you know what to do. Also, with large and complex repositories, the bigger repositories, the harder it is for AI. Yeah, that's it. Then low reliability. The paper reported that I think like 90% of developers were reading every line that AI generated, and sometimes it led to dead ends. So they had to scratch it and start over, or there were like stupid small mistakes that AI could do. So yeah, this is one of the factors, and I think this is getting better every week. I think nowadays. Also, implicit repository context. When there is not explicit knowledge, the developers reported that basically AI behaves like a new contributor to the repository. So yeah, so when there is too much implicit knowledge, also AI is not very useful. Then there was a nice section about comparison of evidence sources for AI capabilities. They basically categorize it into three different clusters. This their random control trial, then benchmarks like SWE or RE bench. Those are soft. Those are basically issues that can be implemented and evaluated by tests, while like classical software development issues, while those are rather algorithms. So the benchmark basically evaluates how well the implemented algorithm performs. So, for example, some machine learning algorithm for classification, so it measures how well it works at the end. So, but those are automatically evaluated, and it means that it means that it basically tests the limits of AI, what AI can do at the limits. While here are some anecdotes, widespread and widespread AI adoption. This is basically rather talking about how people feel about using this AI, whether they think the speed up is there or whether they are satisfied and everything. And this is their study. So to summarize, I would say that this is talking about limits of AI, what it could do, but in very unnatural setup. This is talking about rather feeling how people feel about using AI, and their study is more talking about real use cases and how they perform. That's all. I would like to say also that there are many other graphs in the paper and interesting paragraphs that could be studied. The paper itself has around, I think, 40 or 50 pages. And also, there is a link to one contributor that described whole experience where he think that AI fails based on the experiment and where it worked well. So it is interesting to read. He was, for example, mentioning that he was surprised how AI could not follow some formalized description. So definitely go over it if you like it. Also, I would like to put it into context of that nowadays AI tools are more advanced. We can say that they have definitely better accuracy. The context is extended. It is less error prone. There are many studies now that where they test whether AI generated PRs are merged or they are not merged, and this productivity also increases. Definitely, it's better integration with ID than it was before. Yeah, to be concrete, the study itself is from June 2025. So the implementation, I think, was done in March or April of 2025. Now also ID supports some use of multiple agents that communicate together and they can do tasks in parallel, which was not the case before that much. Also, there are many new MCPs. You can make even custom MCP server, and it works much better now that than it was before. So it's probably quite outdated in this sense. I think the productivity now could be much better. Of course, there are many things that needs to be considered. There are, for example, many MCPs now that AI is trying to use and make it make the response with better quality, but also it can take because of that much longer. So it would be definitely nice to see the same study today, to see how it is different. Let's talk about how it fits KBS's use case. Um, we have many repositories, open source repositories. We have a couple senior programmers and many junior programmers. So for them, for the junior programmers, it seems that AI, according to the paper, could be more useful, probably. And we also use the AI quite heavily with for pair programming or brainstorming with junior programmers. For example, we started to use markdown based diagramming tools because they are very effectively used in real time brainstorming with them. Also, we use those AI conversation to extend the ticket descriptions and so on. We also implemented custom GitHub Copilot agent that is mainly used for knowledge transfer across different repositories, since we have many of them. And when you implement one issue, then it is very useful to have this information when implementing similar issue in another repository. So basically, we are able to search similar issues after writing an issue. And also the implementation, so PRs, commands, and stuff like that. And also with that custom agent, we are checking conventions. Also, we are using mainly GitHub Copilot and Windsurf plugin, formerly known as Codium. Both are they are complementary to each other for some cases. So I'm curious. What are your experience with AI tools? Let's discuss it. Or if you have any question about study, let's do it. Thank you very much. Here are the references. Thank you.